Today we will talk about a very important and advanced topic. A lot of people hate this topic because it's not for beginners, and they feel that it's not important to learn more about this topic. But we will start from scratch. We will explain every point in detail from the beginning, and I think you will like that after this session. Our talk will be about testing in Flutter. I mean here testing in development, not the whole testing as a process in any software product lifecycle. That's called quality assurance or quality control for this product. That's not the topic. We will talk about we will talk about testing in development. But we will take a part of it and we will know more about how to write tests while writing your Flutter application and so on. So, first, let me introduce myself. I'm Tarek Alabd. I'm a software engineer team leader at Megatrust Group. It's a company based in Egypt, Saudi Arabia, and United Arab Emirates. And Google developer expert for Flutter and Dart. A software engineering instructor at Variance. I have more than 7 years of experience in software engineering. I worked on web development, mobile development, and in different technologies, and so on. In addition to all of that, I am a content creator on YouTube. You can find my videos, tutorials, and courses about the basics of programming and problem solving, OOP, Flutter, and Dart, and more than that on my YouTube channel, youtube.com/Tarek Alabd. So let's start from the beginning. And let me ask you our first question. What is testing in Flutter? Testing is a very important phase in the development lifecycle of an application. It ensures that the application is of high quality. So testing requires careful planning and execution. I think it's the most time-consuming phase of development. Yeah, it consumes a lot of time. But really, if you write tests while building your project, that will increase the quality of your code and your project a lot more than building the project without it. So testing is a very important phase in this cycle, in the whole cycle of any project or any product. So Dart language and Flutter framework provide extensive support for the automated testing of an application. You can use simple tools and concepts to build a clean project that we can work to maintain, scale, and many other options. So, generally, there are 3 types of testing processes are available to completely test an application. They are first unit testing, second widget testing, and integration testing. At first, unit testing is the easiest method to test an application. It's based on ensuring the correctness of a piece of code, a function in general, or a method of a class, but it doesn't reflect the real environment, and I think it's the least option to find the bugs. So that's the first type. The second one is widget testing. Widget testing is based on ensuring the correctness of the widget creation, rendering, and interaction with other widgets as expected. It goes one step further and provides near real-time environment to find more bugs. So you don't test the functionality, but the widget rendering and creation. And the last type is integration testing. Integration testing involves both unit testing and widget testing along with external components of the application. So we are trying to test the external components of the project, like databases, web services, and so on. It simulates or mocks the real environment to find all the bugs, but it's the most complicated process because you don't have the database, you don't have the API. You just create a mock for it. You just imagine it like the real one and try to test it. So Flutter provides support for all the type of testing. It provides extensive and exclusive support for unit testing, widget testing, and also integration testing. In this talk, we will take an overview of those three types. At first, let's start with the unit testing. Let me ask you a question. How can you ensure that your app continues to work as you add more features or change existing functionality and so on? For sure, by writing tests. That's it. So you can use the test package because it provides the core framework for writing unit tests, and the Flutter test package provides additional utilities for testing widgets. So there are just 6 steps to produce a good unit testing. First, you can add the test or Flutter test dependency. The test package provides, as I said, provides the core functionality for writing tests in Dart. This is, I think, the best approach when writing packages consumed by web, server, and Flutter apps. Second, we need to create a test file. In this example, we assume you work on the starter project, the counter app. So we have one file called counter.dart. And for that file, we will create another one, counter_test.dart, to test the functionality of the first one, the counter class. So the counter.dart file contains a class that you want to test and resides in the lib folder. The counter_test.dart file contains the tests themselves and lives inside the test folder that you see in the directory of the project. So this is the structure of our code. In general, test files should reside inside a test folder located at the root of your Flutter application or package. And test files should also end with _test.dart. This is a convention used by the test runner when searching for tests. So if you didn't use this convention, that's not testing. Okay? So when you're finished, the folder structure should look like this, as showed in the screen. Yeah. So third, after that, we create a class to test. Next, you need a unit to test. Remember, unit is maybe it's another name for a function, a method, or a class. They are called unit. For this example, we can create a counter class inside the lib folder counter.dart file. It's responsible for incrementing and decrementing a value starting at 0. So for sure you can add the encapsulation here by making the value attribute as a private variable and the setters and getters, and for sure add the required functions like increment and decrement and so on. You have you are free to write your code. So one note before we continue, for simplicity, yeah, I didn't follow the test-driven development approach in this talk, and maybe we can talk more about it in another session and so on. So if you are more comfortable with that style of development, you can always go that route, and I really encourage you to do that. So after that, fourth, we need to write a test for our class. Now, in this step, we will start to write our first test cases for our class. Inside the counter_test.dart file, you can write the first unit test, your first unit test. Tests are defined using the top-level test function and you can check if the results are correct by using the top level expect function. Both of these functions come from the test package, that we imported in the pubspec.yaml in the sixth slide. Okay. So at first, we must write all our tests inside the main function. Inside it, to make a test case to test a specific functionality, we can use the test function. For example, I want to test the functionality that's responsible for incrementing the counter or decrementing the counter. So let's talk more about incrementing the counter. I want to verify that everything is working good and the counter incremented. So I'll call a test function in the first and in the first parameter we add the description for this test case, like a counter value should be incremented, or if we test the decrement feature, we can change it as you want. So we add the description for this test case, and the second one is a void callback, or we can call it the body of the test case. It's a void callback or the body of the test case. So here we created an object from this class. We need to test its counter. After that, using expect function, we expect the value of this counter object after incrementing. I expect the result will be 1 after one hit, after the user hit the button for one time. The value will be 1. So I should expect its value, and the second one the value itself. So until that, congratulations, you wrote your first test case. 5. Combine multiple tests in a group. In a single project, you have more than one test, so you need to group those tests. If you have several tests that are related to one another, combine them using the group function provided by the test package. After that, you can run the tests. Now that you have a counter class with tests in place, you can just run the tests. You can run the tests by executing the following command from the root of the project, flutter test, and the location of the file you want to test. And for more options regarding unit tests, you can execute this command, flutter test --help. And that's what we need to know about unit testing. The second one, widget testing. A widget test in other UI frameworks referred to as a component test. It tests a single widget. The goal of widget testing is to verify the widget's UI looks and interacts as expected. For example, if we click on this button, it will perform the expected behavior or not. So testing a widget involves multiple classes and requires a test environment that provides the appropriate widget lifecycle context. For example, the widget being tested should be able to receive and respond to user actions and events, perform layout, and instantiate child widgets. So the widget testing is more comprehensive than a unit test. However, like a unit test, a widget test's environment is replaced with an implementation much simpler than a full-blown UI system. Okay. So to test widget classes, you need a few additional tools provided by the Flutter test package, which ships with the Flutter SDK. The first one, the widget tester. It allows you to build and interact with widgets in a test environment. The second one, the test widgets. It's a function automatically creates a new widget tester for each test case, and we can use it in place of the normal test function. The third one, the finder classes, and it allows us to search for widgets in the test environment and so on. If we need to find any widget in this screen, we can use the finder class. And the fourth one, widget specific matcher. It helps verify whether a finder locates a widget or multiple widgets in the test environment and so on. So if this sounds overwhelming, don't worry. We'll learn how all of these pieces fit together throughout these steps. At the first step, we need to add the Flutter test dependency. And for sure, we added it in the dev dependencies because we need to use it while developing, just developing. So the second step, we need to create a widget to test. Create a widget for testing. I used this simple widget that displays a title and a message. It's a basic UI. So the third step, we need to create a test widgets test. With a widget to test, begin by writing your first test. Use the test widgets function provided by the Flutter test package to define a test. So the test widgets function allows you to define a widget test and creates a widget tester object to work with. This test verifies that my widget displays a given title and a given message. It's titled accordingly and will be populated in the next section. So this test widgets function is like the test function in unit testing, but with the widget tester in the second parameter. So after that, we need to build the widget using the widget tester. We need to build my widget inside the test environment by using the bump widget method provided by the widget tester object. The bump widget method builds and renders the provided widget. So create my widget instance that displays T as the title and M as the message. So after that, we search for our widget using a finder. With a widget in the test environment, search through the widget tree for the title and the message text widgets using a finder. You can search for them using a finder, and this allows verification that the widgets are being displayed correctly. For this purpose, you can use the top-level find method provided by the Flutter test package to create the finders. So since you know you're looking for text widgets, you can use find.text method and write something that you search for in the parameters. After that, we need to verify the widget using a matcher. Finally, we need to verify the title and message text widgets, and they appear on the screen using the matcher constants provided by Flutter and test, Flutter_test. Matcher classes are a core part of the test package and provide a common way to verify a given value meets expectations or not. Ensure that the widgets appear on the screen exactly one time. So for this purpose, we can use the find one widget, and it's a type of the matcher. So we expect the title finder object equals to the finds one widget. That means this title exists and the matcher found it. There are for sure there are a lot additional matchers like finds nothing, finds widgets, and so on. You can find them in detail in the documentation and so on. After that, integration testing. Unit tests and widget tests are handy for testing individual classes, functions, or widgets. However, they generally don't test how individual pieces work together as a whole or capture the performance of an application running on a real device. These tasks are performed with integration tests. Integration tests are written using the integration test package provided by the Flutter SDK. In this short talk, we will learn how to test a counter app. It demonstrates how to set up integration tests, how to verify specific text is displayed by the app, how to tap specific widgets, and how to run integration tests. The first step, we need to create an app to test. First, create an app for testing. So in this example, we can test the counter app again, the starter project when creating a new Flutter project. This app allows a user to tap on a button to increase a counter and so on. The second step, we need to add the integration test dependency. Next, use the integration test and Flutter test packages to write integration tests. Add these dependencies to the dev dependencies section of the app's pubspec.yaml file and specifying the Flutter SDK as the location of the package. After that, we need to create the test files. Create a new directory integration underscore test with an empty file app underscore test.dart. After that, we need to write the integration test we need. Now you can write tests. This involves 4 steps. The first one, initialize integration test widgets Flutter binding. It's a singleton service that executes your tests on a physical device. The second one, interact and tests widgets using the widget tester. And the third one, you can test the important scenarios. And everything, everything you can know more about integration testing because it has a lot of details, but that's the basic concept for the unit testing, integration testing, and widget testing for sure. Finally, we need to test on mobile. To test on a real iOS or Android device, first connect the device and run the following command from the root of the project: Flutter test integration test, and your path and the path of the file contains the tests, and that's it. You wrote your first unit testing, widget testing, and for sure integration testing. So that's it about testing. If you have any questions about testing in Flutter.
Yeah, so then we have how can I do basic testing for data classes? I mean, what things should I test in a data class?
You mean the data layer? That's right.
Yeah, I agree.
Okay. It should you should test the integrations you did with the APIs, the databases, or everything. You should at first mock the APIs or the database and expect the value, and you build the mock for this database and expect the value coming from this database or the API for each request you send. So that's it in the data layer, because the data layer you should use it to communicate with the third party or with the APIs and databases and so on. So you just test these requests and so on.
Okay, great. And we have another question from Zainul Hassan. He's saying, I always find it hard to write tests before I write actual code, because I do a lot of changes before the actual code is final. How can I get better at writing tests before code and follow TDD? How may I train my mind to adopt it? So it's, I think, more of a personal question.
Okay, I think you can write the tests before you write the code, or use the TDD concept if the whole business is clear for you. Don't I think it's not good if you use TDD and the business of your project or your application or the business you work on it is not clear for you, because you don't know how or you don't know the changes that will be in the future and so on. So you should have all the information about this business right now, so you expect everything, like everything you deal with, like the databases, the APIs and the responses coming from the APIs and so on. So don't use TDD if you don't have the whole business and so on. Thank you, Fawad, and thank you, everyone.